Hello everyone. Let's discuss about the topic Introduction to Multithreading in Unit 4. So, to talk about multithreading is a programming concept where a single application is capable of executing multiple threads concurrently. So, this enables program to perform multiple tasks simultaneously rather than sequentially. Then the key concepts are concurrent execution, independent threads, and efficient resource utilization. So, to talk about concurrent execution, multi-threading allows different parts of a program to run independently at the same time. For example, in a text editor, one thread can handle user typing, and another can auto-save the file, and another can check for spelling errors. So, all these are running concurrently. And the second one is independent threads. So each thread operates as an independent unit. That means one thread's action do not directly impacts the others. This independence makes application more efficient. And the third one is efficient resource utilization. So threads share the same memory space, making communication between them more easier and more efficient. So now let's see the use of multithreading. So by executing tasks in parallel, the overall execution time of an application is reduced. Then the example of multithreading in real life is a web browser and gaming. So in web browser, a browser can load a web page in one thread, play a video in another, and handle user input in a separate thread. And in gaming, threads manage tasks like rendering graphics, processing user input, and running background logic simultaneously. So next, let's see the benefits of multithreading. The benefits of multithreading are responsiveness, resource optimization, and simplified designs. So, to talk about responsiveness, multithreading ensures that application remain interactive even when performing resource intensive tasks. For example, a mobile app can continue to accept user input while downloading data in the background. And the second one is resource optimization. So threads use available CPU cores efficiently, which enhances the overall system performance. And the third one is simplified designs. So by dividing complex tasks into smaller and independent threads, developers can design modular and scalable applications. So this also makes the code base easier to manage and maintain. So the next topic is thread creation. Let's see how threads are created using several approaches in Java. So it can be created by extending the thread class. So create a new class that extends the thread class and override the run method. Then the second one is implementing runnable interface. In this, create a class that implements the runnable interface and pass its instant to a thread constructor. And the third one is by using thread pools. So Java provides built-in thread pools to manage and execute tasks efficiently. So the next topic is threads life cycle. So there are few stages in life cycle of thread. They are new, runnable, running, blocked, and terminator. So in new stage, a thread is created but hasn't started yet. And the second stage is runnable. So here the thread is currently so here the thread is ready to be executed and it is waiting for the CPU to handle it. And the third stage is running. So here the thread is currently executing its tasks. And the fourth stage is blocked. So here the thread is waiting for a source to become available. So simply say it is temporarily stopped there. And the last stage is terminator. So here the thread has finished its execution or has been stopped. So now let's see the methods that are available under the thread class. So they are start, run, sleep, join, get priority, get name or set name. So let's see few of them. So in start method it begins the execution of the thread, and in run method it contains the code that defines the task the thread will execute. And in sleep method which temporarily pauses the thread for a specified time. So each and every method has its own function. So finally, let's see an example program for a thread class. So here we creating a class A which extends the thread. Then in that we are using run method to print a value from 0 to 5. And we again creating a class B which also extends the thread. In that we again using run method to print a value from 10 to 5. And at last we creating a main class as thread proc. In that we creating an object for class A and class B, and we calling it through the start method. So the in output it will be executed concurrently, and it gives the different output for different execution of a program. Thank you.